Today we are going to start with algebra. Today we are entering our specific topics of the semester. So the first thing, it's important to define some stuff before going to actual exercises and everything. So first we are going to define algebra. Algebra is the branch of math that use letters or variables to represent numbers. So that can be a little definition about algebra. Then we are going to define three specific topics that are very important for us. The first one is algebraic expression. We can define an algebraic expression as one or more algebraic terms that include variables, constant, and operating symbols. That means that if I have something like this, 5x plus 7y minus 2 zeta, that's an algebraic expression. One or more algebraic terms that include variable, constants, and operating symbols. Now, what is an algebraic term? Algebraic term can be a number, a variable, letter, or a constant multiplied by a variable. So let's see, it can be a number. If we have number 5, that will be also an algebraic term. If we have a letter, maybe y, will be also an algebraic term. If we have like a constant multiplied by a variable, maybe 2/3 multiplied by x, that will be an algebraic term. Also, if we have like 7x squared y, that will be also an algebraic term. So that's the definition for algebraic terms. Here we have an important note. We can know or remember that algebraic terms are separated by a plus or minus sign. That means that if I have like something like this, 5 plus 3x, that means this is an algebraic term, this is another algebraic term. If we have something like, I don't know, maybe 2/3 x squared y zeta to the fourth minus 7/4 x squared y zeta. So in this case, this will be an algebraic term, and this can be another algebraic term. So always remember, algebraic terms are separated by a sign. It can be a positive one plus or a negative one minus. We can also define what it's like terms. Like terms are those terms that have the same variables and also those variables raised to the same powers. That means like if we have 5x and 2/3 x, they are like terms because both of them have the same variables, in this case x, raised to the same power, in this case 1. So if we have like something like this, maybe 7/5 y to the 7 and maybe 3y to the 7 will be also like terms because both of them have the same variable, in this case y, and raised to the same power, in this case 7. We will put here another example. So if I have something like 2x squared y zeta and maybe 1/3 x squared y zeta, both of them will be also like terms because they have, as I was telling you, the same variables, x squared, y, and zeta, and they have the same powers. X is squared in both, y is to the 1, and zeta it's also to the 1 power. So these are three specific definition, expression, term, and like terms that will help us very much in the future So I recommend you to do a little note about them because they will help you much in the future. So let's see other stuff. We can also define these three specific topics that will help you also in the future. The independent term, when we are talking about an independent term, we are talking about a term with no variables. It is also known as a constant or a number. If we have only the number, the arithmetical number, not a variable or letter, that will be an independent term. We will have also what it's called common terms. Those terms are exactly the same. That means that they have equal constant and also equal variables. Remember in the last screen we saw like terms. In like terms we have the same variables but maybe not the same constant. In common terms we need to have the same constant and the same variables also. And in the last part, we will have symmetrical or symmetrical terms, terms that have the same constant and variables but different sign. That means maybe 5 minus 5, maybe x minus x, maybe 3x squared y minus 3x squared y, maybe 2 7 ABC minus 2 7 ABC. Those will be symmetrical terms. That means they are exactly the same but with different sign. So these will be some specific definitions that will help you a lot on the next classes. So please have them there in your notebook because they will help you a lot for the next topics. So now we will see the elements of an algebraic term. In this case, we have like maybe these parts, the most important of them. We need to know them and identify them on all the algebraic terms. The first part is the sign. It can be positive or negative. So this, in this case, will be the sign. We will also have the coefficient that includes the sign and the constant that will be the number or the fraction or the number that it's multiplying the algebraic term. So in this case, the sign and the number will be the coefficient. Then we will have the base that is composed by the variables and their powers. So this will be the base. It says that it's composed by the variable and the powers. These three together will be the powers, and the letters x, y, and z will be the variables. So those are the most important elements of every algebraic term. So if I have another term, maybe I will put it here. I don't know, something more easy. 5x to the fourth. That will be, or it will have the same, it will have a positive sign that sometimes it's not directly put it, but we can know that the number is positive. So this will be the sign. This will be the coefficient. This will be the base. This will be the exponent or power. So this was the sign. This was the coefficient. So we have coefficient, base, exponent, and letter x will be the variable. So that's the way that we can like look at the elements of an algebraic term. And it's very important for you to know that every algebraic term has these elements: sign, coefficient, and base. So please put it in your notebook because it will be very helpful for you to know the elements of an algebraic term. Now we will see a classification or types of algebraic expression by the number of terms. That's very important. The first that we are going to see is the monomial. Monomial consists of only one term. That's very important. So monomial, monos, one in Greek, it's only one term. So we will have maybe some examples. We can have like 3x. Maybe we can have 2/3 x squared y z. Maybe we can have something like this: 2 minus 5a to the fourth divided by m. I'm sorry, let me put it, yeah, by m. That can be a monomial. We can also have a monomial if it's on parentheses. If we have something like this, 2x minus 5, but if it's on parentheses, it could be also known as a monomial because this is only one expression, so it's not separated by other signs. So if it's an expression between brackets or parentheses, can be also called a monomial. Maybe we will understand it better with the next specific exercises. We will have also the binomial that consists, of course, bi, it's 2 in Greek, so we will have here two terms. So let's put some examples. Maybe we can have something like 3x plus 2y. That will be a binomial. We can also have maybe 2/3 x squared y zeta minus 5. That will be also a binomial. Maybe we can have something like 2 minus 4th over m plus x squared. That will be also a binomial. And to have a binomial in parentheses, we need to have something like this. Maybe the same that we have on the top, 2x minus 5. That will be a binomial because it's on parentheses, but then we can have another sign, and this will be a binomial because that expression that it's on parentheses, it's a monomial. Then we have the addition sign, and we have another monomial, so this will be join a binomial because we have two different terms. Remember, if something is between parentheses, we can tell like it's a monomial because it's only one term. Let's continue with the third one. That will be trinomial, from the Greek tri. So that will be three terms. We can have maybe something like this: 3x plus 2y plus zeta. Maybe we can have something like 2/3 x squared y zeta minus 5 plus 7x. That will be also a trinomial. Maybe we can have something like, I don't know, 2 minus 5a fourth over m plus x squared minus 5 y that will be also a trinomial, and maybe we can have something like minus a plus 2x plus 2x minus 5. This will be also a trinomial because we have here a monomial, here a monomial, and here a monomial. So that's why when we have something in a parenthesis, remember we can treat it as a monomial. So this will be a trinomial. And we will have also a different one that will be polynomial. And the definition of polynomial is when we have more than one term. That means that binomial and trinomial are also polynomials, because polynomials can be with 2 terms, with 3 terms, with 4 terms, etc. So binomial and trinomial are also a polynomial. So that will be the typical classification of algebraic expressions: monomial, binomial, trinomial, and polynomial. So I will do some examples of having different algebraic expressions and classifying them as monomials, binomials, trinomials, and polynomials. Let's see some examples. So let's see, we are going to do these exercises when we need to classify the expressions as monomials, binomials, trinomials, or polynomials. So we will see in the first one, we don't have any plus or minus sign. So this expression, it's only one term. So we can classify it as a monomial. In the second one, we have a minus sign, so we will have this term and this term. So we will have two terms, so this will be called a binomial. On the third case, we need to be very careful because remember, when something is on parentheses, we can classify it as a monomial, and the number 2, it's multiplying that monomial. There is no an addition or subtraction side after or before the expression. So this full expression, it's a monomial, because remember, if it's on parentheses, it's a monomial if we have only a number multiplying that parenthesis. It's the same term, so this will be only a monomial. So this is very important because it can get a little tricky for some of you. The next one is very simple. We have one term here, another term here, another term here, and another term here. So it will be, because of 4 terms, we can classify it as a polynomial. And the next exercise, we need to be also very careful because this is one term. Remember, if something is on parentheses or brackets, must be also only one term. So this is only one term, completely only one term. And the other one, it's also only one term. So we will have a trinomial. I will do some other exercise to get more clear idea of classifying expressions as monomials, binomials, polynomials, but it's a very simple task to do when you have practiced a lot. So let's do these exercises. So in the first case, It's very important, like we are going to see terms. This is the first term. This will be the next term, because as parentheses, when we have roots, we can like classify it as only one term. This is another term. This is another one. So we will have four terms. So we will call it polynomial. In the next one, we have like this specific term, this specific term, and this one. So it's very easy. We have three of them. So it will be a trinomial. The next one can get a little tricky because maybe we see only the inside of the bracket. We can see three different terms. But remember, if something is between brackets or parentheses, can be used as a monomial. So this is a monomial. If it gets multiplied by a number, it stays as a monomial. So this will be only a monomial. The next one can get also a little bit tricky because this is inside a parenthesis, so it's a monomial. If it's multiplied by a number, it stays as a monomial. So the next one, it's also something that it's on parenthesis, so it's a monomial. If it's multiplied by a number, it stays a monomial. So we have two monomials. That will be a binomial. And in the next one, it's also very tricky because we have something in parentheses multiplied by a number. So that will be a monomial. We will have here another one, here another one. So we have three of them. So this will be a trinomial. So that will be it of doing exercises to classify expressions as monomials, binomials, trinomials, or polynomials. I will do only another slides with some notes that will be important for you on these kind of topics. So these are three important notes that will help you also when writing or seeing algebraic expressions or terms. The first one is that we don't need to write the exponent if the power is number 1. That means if we have something like, I don't know, maybe 5x, we don't need to put like x is power 1. We know that if it's no number here, we know that that will be power 1. So we don't need to write power if it's 1. The second note is we don't need to write the coefficient if the number is 1. That means if we have a 1x, we normally don't put the 1. We also don't do it if it's negative, if we have minus 1yz. In this case, we also don't need to write the 1. We need to left the negative sign, but we don't need also to write the coefficient number if it's 1. And the last note is that we don't need a positive sign. It is if the first term of an algebraic expression. That means if I got something like 5x plus 7y minus 2, minus 2 zeta. In this case, we don't need to have like or specify like the first term it's positive. If we don't see here a sign, that means it's a positive one. So we don't need the positive sign on the first term of an algebraic expression. So these three like little notes will help you also. So please have them in mind for the next classes. That will be all for today. Thank you. You can do now activity 10.